Alright, so this video is going to be part 2 of our ratio test practice. So again, we're being asked to prove whether the series converges or diverges using the ratio test, and we have our first series up on the board, the sum from n equals 1 to infinity of 2 to the n over n squared. So we can write this as the limit as n approaches infinity of, this is now a sub n, right, the absolute value of a sub n plus 1 over a sub n. So we have a sub n plus 1 on the top, that's going to be this, but instead you're plugging in n plus 1 in for n, so we get a 2 to the n plus 1. That is going to be put over n plus 1 quantity squared. Now that's going to be over just our regular a sub n, that's going to be 2 to the n over n squared. Alright, now we can flip this denominator up into the numerator to get the limit as n approaches infinity of the, and do we actually need that absolute value anymore? Well, all these terms are positive, so we really don't need that. Okay, we can end up with just, this will be 2 to the n plus 1 over 2 to the n, okay, times, this will be n squared over n plus 1 squared. So now, what is going to happen to this first little part right here, this 2 to the n plus 1 over 2 to the n? Okay, well that is just going to be 2 because you have an n plus 1 minus n, that's just left with a 1, right? That's 2 to the first power, which is 2. Now, next we have an n squared over n plus 1 squared, or quantity squared. Now, for this, really, we can just distribute that out. Okay, we can FOIL that out. We can get n squared plus 2n plus 1. Okay, so you'll see that right here. We get n squared over, just FOILing that out, we get n squared plus 2n plus 1. Now, we can put this 2 right in here, okay, to get 2n squared. Now, you'll see that you can either divide everything by n squared or do L'Hopital twice, but you'll end up with this limit equaling 2, which is greater than 1. Okay? Now, of course, I put that greater than 1. If you're wondering why I put that there, it's because that is, you know, we need to see if this number is greater than, less than, or equal to 1, of course, right? Because that is going to tell us whether this is absolutely convergent, divergent, or inconclusive. Now, since it's greater than 1, that means that it is going to be divergent by the ratio test. Alright, so we have our next problem up on the board here. We have the sum from n equals 1 to infinity of negative 1 to the n times 5 to the n over n factorial. Okay, so again, let's set up that limit. We get the limit as n approaches infinity of our a sub n plus 1. That's just going to be a negative 1 to the n plus 1 times 5 to the n plus 1 over a n plus 1 factorial. And that's all going to be over, this will be just what it says right there, negative 1 to the n times 5 to the n over n factorial. Okay, now we get this all into one fraction. We get the limit as n approaches infinity of, let's not get rid of the absolute value sign yet because we still have to deal with those negative 1s. Okay, so we get the limit as n approaches infinity of, we can start separating this off into parts here. We're going to get a negative 1 to the n plus 1 over, this will be a negative 1 to the n. Now, we're going to have that being multiplied by a 5 to the n plus 1 over 5 to the n. And we will, of course, have a n factorial over n plus 1 factorial. Alright, and this is all stuff that we've dealt with before, so it's really nothing too complicated from this point forward. Okay, so negative 1 to the n plus 1. Well, we have this n plus 1 minus n here. Okay, so this just is going to become negative 1. Okay, negative 1 to the first power, which is negative 1. And, oh, forgot the absolute value signs here. Yeah, cool. So that negative 1, that just becomes 1 because we can drop those absolute value signs now and that gets applied to the negative 1, right? So really this just becomes 1, so it doesn't really matter. We have a 5 to the n plus 1 over 5 to the n. That's going to do the exact same thing as that negative 1 just did. This will become 5. Okay? So we have a 5 so far out of the first two. And we have an n factorial over n plus 1 factorial. We've been over this before, right? This just gets broken apart into an n plus 1 times n factorial. The n factorials cancel out. And you're just left with the n plus 1 on the bottom. So you get a 5 over, I guess I can put it like this, 5 over n plus 1. You take the limit as n approaches infinity, you'll get an infinitely large denominator, which of course means that this limit will end up equaling 0. 0 is less than 1, which means that this is absolutely convergent, and therefore convergent using the ratio test. And that's going to be it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the ratio test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.